Welcome back to Java Space. In this video, I want to talk about everything that you need to know about the application context. So, before we talk about application context, I want to talk about the container itself, because application context is also a container, by the way. So one of the main features of the Spring framework is the IOC, Inversion of Control container. The Spring IoC container is responsible for managing the objects of an application. It uses dependency injection to achieve inversion of control. So I have noticed that some developers, they confuse dependency injection with inversion of control. So these two are different. How are they different? With IOC, we are saying we are transferring the control of objects, the initialization of object, the instantiation of object, and the life cycle to a container, to a framework, which means that in our code, we are no longer going to be initializing, instantiating, or doing life cycle management. Something else is going to do that for us. Think of this like a relationship between Apple and China. Apple, they are the owners of iPhone, they are the owners of iMacs, but they do not produce them. Someone else produce them and for them. So think of that analogy. So the dependency injection. Dependency injection is a technique in which an object receives its dependencies, or the object it requires, as opposed to it actually creating them internally. So now what you notice is that dependency injection is a subset of IOC. So with IOC, we are saying, in addition to creation or to giving an object dependencies, those dependencies that you are giving to that object, we also manage them, the life cycle. So that means dependency injection does not have to do with life cycle management, but IOC container deals with dependency injection and life cycle management. That is how you can differentiate between those two. So what is the advantage of all this? The advantage is that we have loose coupling between objects. You know that loose coupling, the advantage is that your components are not tightly coupled to one another, and tight coupling leads to sensitivity between components, which means a component becomes too sensitive to another component, which is not what we want. We want components to be independent, such that a change in one component does not really imply a change in another component. When we change one component, we don't really need to do changes, or we still need to do, but it shouldn't be that kind of a tight relationship. Then we can easily switch implementations, because an object is not creating dependencies itself, it's receiving them from outside, which means we can easily give that object the different dependencies. And another thing is, when we test our application, because of all this dependency injection, we can easily test those components because they're isolated, they're independent from one another. So we can unit test a component and the object it receives, or its dependencies. We can pass the fake objects, because we are interested in testing A, and A depends on B, but we are not interested in P. So what we can do, we can give A fake B, which is actually referred to, or obviously it started as stubs. You give it a stub, but as programming evolved, got modernized, instead of create a stub is like a manually created class, but there is what also we call a mock, which is a class but you don't manually create it. And the most important thing with the mock is that you can also control its behavior, how it should behave. All right, so we give a fake object, we give a mock because it's isolated, and we give it the object it actually requires. And also, we don't have to create those objects ourselves. The container will do that for us. And also, we don't even have to manage those objects ourselves. Then, now back to the application context. The Spring container has or started with these two main I wouldn't say it started with them, but these are always standing out like all the time. Even when some of us started coding, these are always the the containers, or you can say interfaces, that always stand out. The bin factory and the application context, they represent the Spring IoC container. The bin factory is the root interface for accessing the Spring container. It provides basic functionalities for managing bins. The application context is a sub-interface of the bin factory, which means it offers the functionalities of the bin factory and additional more enterprise features like resolving messages, internationalization, event publishing. So previously we talked about bins while we were defining the container, and IOC, inversion of control and all that. So in Spring, a bin is an object that is managed by the Spring container. So what it does, it will instantiate that object for you, initialize that object for you, assembles it, and manage the dependencies or the life cycle of that object. The difference between the bin factory and the application context. The application context has all the features of the bin factory, and it has some additional features that are not present in the bin factory, which I've mentioned: the internationalization, event publishing, AOP features, and many more. Bin factory loads bins on demand, so which means it uses lazy loading. Only when you require a bin, then that it gets loaded for you. Whereas application context, bins are loaded when you start up your application, which is eager loading. So bin factory does not support annotations, whereas application context does support annotations. The bin factory only supports two scopes, which is singleton and prototype, whereas application context supports many scopes. You have you have request scope, you have sessions, you have and many other scopes that you can find in Spring application. The bin factory does not register bin factory post processor and bin factory. The bin factory does not register bin factory post processor and bin post processor automatically, whereas the application context registers them automatically. So before we conclude our video, I want us to look at common application context. Obviously, we talked about the bin factory, which is the root, which is on top of all of them. Then we have the application context. Then we have the configurable application context. Then you have the class path XML application context, the file system XML application context. You have the web application context. You have the annotation config application context. Then there is a Groovy web application context, the reactive web application context. So based on the dependencies you have on the class path, Spring will know which application context it has to wire for you. Mhm. So let me start with the web application context. Obviously, this is applicable when you are creating a web application like in Spring MVC, REST, or just web application. Then you know that you are going to have web application context wired for you, and you know that if you include as a dependency Spring Boot Starter Web, then you are creating a web application. So then it means the web application context will come into the picture. But now let's say you are creating a reactive web application. You don't use Tomcat. You either use under Tor and Netting or Jet. So in that case, we are talking about a reactive web application context, which is optimized for that reactive environment. Then also we have Groovy web application context. Then we have, which is obviously making sense in when you are dealing with Groovy scripts and all that. Then you have class path XML application context. So this you use when you are loading. In older version of Spring, when we were still depending on XML configurations. So if you put your XML configurations in the class path inside the resources folder, then you can use this class path XML application context. But if those dependencies are somewhere in your computer or they are online, you can use the file system XML application context to load those for you. So before we conclude, I want us to look at all this quickly in the code. So as you can see, we have, I want to start with the application context. Let's see the bin factory. They say it's the root interface for accessing the Spring Bean container. All right. Then let's go to the application context. I want us to see different implementations here. The application context, we have quite a number of them. We have the web application context, which I have explained, provides configuration for web application. Okay. Then we have annotation configuration application context, a standalone application. So if you're just creating a Spring application that is standalone, you can just use this application context. It's sufficient to do everything you want for yourself. Okay, let's check another one before we conclude. Then we have the configurable application context. So they are saying the SPI interface to be implemented by most, if not all, application contexts, and it provides facilities to configure an application context in addition to application context client method in the application context interface. And also I have explained the class path, XML in the class path. Then also I want us to look at we have the reactive, we have explained it also. As you can see, we have even much more than I have listed in the slide. So it says the implementation, it says the web application context implementation, which takes its configuration from a Groovy bin definition script and or XML files as understood by the Groovy bin definition reader. All right. And then you have static application context. Some of them, to be honest, I don't even know them. But if you know this, basic ones that I've mentioned. So they are saying the application context is the central interface to provide configuration for an application. This is a read-only while the application is running, but may be reloaded if the implementation supports this. It says an application context provides bin factory methods for accessing application components, the ability to load file resources in generic fashion, the ability to publish events to registered listeners, the ability to resolve messages, supporting internationalization, inheritance from parent context. Definitions in a descendant context will always take priority. So this is just them defining the application context. So guys, thank you for watching this video. See you in the next video.